Assalamu alaikum guys. Okay, so in this lecture we are gonna solve this paper of A-level chemistry 9701 paper 11. It's basically AS chemistry that we are gonna do, and the time allotted to you guys is 1 hour. We'll do the first 10 questions in this video. Alright, so now the first question. Use of data booklet is relevant to this question. All right, let's see what they are asking. What could be the proton number of an element that has three unpaired electrons? Okay, electrons are unpaired, means they are singly arranged in each of these atoms. All you need to do over here is to find out whether the electrons are unpaired or not. These proton numbers, since these are atoms, so the number of protons and electrons are equal. Just write down the electronic configuration and you'll get an idea. Okay, the first one is 5 protons, so 1s2, 2s2, 2p1. The second one, this is the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p1. The third one is 1s2, 2s2, 2p6, 3s2, 3p3. Okay, in the last orbital, in the p orbital, if you can you look at the p subshell, there are 3 electrons in here, and since you know that the p subshell contains 3 electrons and each electron according to the Hund's rule will get singly filled, so this it's the option C that contains 3 unpaired electrons. All right, so C is going to be the correct answer. And moving on to the next part, the elements radon, francium, radium have consecutive proton numbers in the periodic table. What is the order of the first ionization energy? Again, the use of data booklet is relevant. Now let's look at the periodic table now. All right, if you look at the periodic table, this is the trend of ionization energy. It increases up ascending the the group. It increases across the periods from left to right. Okay, so now I've highlighted radon, francium, and radium, the elements that are given in the question. Radon, as you guys know, is a noble gas, so it must have a very high ionization energy. Plus, it is above these both of these elements in the in in the group, and also it's on the right hand side. So radon must have the highest ionization energy, meaning it must have the most endothermic ionization energy. Now, what about francium and radium? Well, if you look at the trend going across the period, ionization energy decreases. So radium must have a lower ionization energy as compared to francium. So francium has a greater ionization energy as compared to radium. So this is the trend. Radon followed by francium and then followed by radium. Okay, so the most endothermic is the ionization energy of radon, then followed by francium, and then followed by radium. All right, so radon, the most endothermic is radon in option A or C, but then comes francium or radium. All right, so since we know that it's radium, radium has a greater ionization energy as compared to francium, so it's option A. Now, what about MCQ number 3? Which gas closely approaches ideal behavior at room temperature and pressure? Okay, guys, so for this question, you guys have to know the fact that ideal behavior is shown by the gases, or ideal gas is the gas that contains no intermolecular forces. So the gas that approaches intermolecular ideal behavior is going to be the gas that has the weakest intermolecular forces. Ammonia form hydrogen bonds. Ammonia will have the strongest intermolecular forces. Carbon dioxide, helium, and oxygen, they all these have van der Waals forces. But van der Waals forces, it depends upon the number of polarizable electrons present in the element. Basically, it depends upon the number of electrons present in the element or in the atom. Is helium that has the least number of polarizable electrons. So it's option C because it will have the weakest intermolecular forces. Moving on to the next MCQ. Number 4. Okay, these are some energy values given of bond energies, and then these reactions are given. PQRS. Then what is the order of enthalpy changes from most negative to most positive? Most negative to most positive, meaning most exothermic to most endothermic. Guys, for this MCQ, you guys need to know the fact that exothermic reactions are those which are bond forming reactions. Bond forming reactions are exothermic, whereas bond breaking reactions are endothermic. Bond breaking are endothermic. So let's see where the bonds are broken and where the bonds are made. Now, I have assigned the bond energies. How have I assigned the bond energies? In the P reaction, bromine is broken down into two bromine atoms. This means that bromine-bromine bond has been broken down. Since this is a bond breaking reaction, it's an endothermic reaction, and the energy is 193. So plus 193 kilojoules per mole is going to be the enthalpy change of this reaction, because this is a bond breaking reaction, therefore it is an endothermic reaction. Then what about Q? In Q, two atoms are joining to form a molecule. This is a bond forming reaction. Again, it's going to be an exothermic reaction because bond forming are exothermic, and chlorine's data is given right over here. It's 244. So negative of 244. Then a methyl group is combining with a chlorine atom. So if again a bond is being formed between carbon and chlorine atom, so if carbon and chlorine bond is being formed, so it's again going to be an exothermic reaction, and the data is given over here is 340, but negative of 340 because it's exothermic reaction. And the last one is bond breaking reaction, because one hydrogen atom is removed, so one carbon hydrogen bond is broken, so it's going to be a positive reaction, plus 410. This is the most positive one. All right, so most positive has to come in the last, so it's either option A or option C. Okay, S and S. Now what about P and R? Okay, which of them is more positive in P and R? Obviously P is more positive because it's plus 193, so P, then followed by Q and R. Option C is the correct answer. Now let's move on to the next part. All right, Hess's cycle, Hess's law. Okay, these are the enthalpy changes given. What is the standard enthalpy change of formation of iodine trichloride? For this question, you guys need to know what the definition of enthalpy change of formation is. Enthalpy change of formation is the enthalpy change of a reaction in which 1 mole of a compound is formed from its elements, but under standard conditions in their standard states, because they're asking us the standard enthalpy change of formation. Now, iodine in a standard state is a solid. Chlorine in a standard state is a gas. They'll both combine forming 2 moles of ICl3, and the enthalpy change of this reaction is going to be twice of enthalpy change of formation, because 2 moles of ICl3 are formed in here. Now, iodine solid has been converted into iodine gas, and then this gas has been reacted with chlorine gas to form ICl3. Now this gas data is given. So iodine converts into gas. Its enthalpy changes plus 38 kilojoules per mole. All right, chlorine is written as it is. There is no change in enthalpy, so I'll put a 0 on its arrow. Now, if iodine gas combines with 3 moles of chlorine gas, it forms 2 moles of ICl3 solid, right? So it's basically this reaction, and its enthalpy change is given. I've marked it, I've shown it over here by this last arrow. Now our Hess cycle is complete. Okay, once our Hess cycle is formed, just add up the vectors, just add up the arrows. Okay, just add up these two arrows and this arrow. Okay, the arrows which are pointing in the same direction must be added up. So going down and then moving up. Whereas this arrow over here, it points in a different direction. So just add them up. 38 plus 0 plus minus 214 will equal twice of enthalpy change of formation. And then calculate the value of enthalpy change of formation. That turns out to be minus 88 kilojoules per mole. You can also think of this as vector addition. All right, just head to tail rule of vector addition that you did in your AS physics. Consider these two as the two vectors pointing in the same direction. Add them up to get a resultant vector pointing downwards. And then what about this one? This is one that has been placed, right? Its tail has been placed on top of it. All right, so these are the two vectors that are added up to give you a third resultant component, and that resultant is the twice of enthalpy change of formation. So you can also think of this as vector addition. All right, now moving on to the next part. Ammonium nitrate can decompose explosively when heated. All right, so what are the changes in the oxidation numbers of the two nitrogen atoms when this reaction proceeds? Okay, what happens to the oxidation? What are the changes? They are actually asking you the change in oxidation state. They are not asking you the oxidation numbers. So first you assign the oxidation numbers in each of these nitrogens. Okay, in ammonium, I've solved it over here. The oxidation state of nitrogen is -3 in ammonium ion, and in nitrate ion is +5. Okay, -3 and +5. And what about N2O? In N2O, In N2O, the oxidation state turns out to be +1. So what's the difference between +1 and -3, +1 and +5? Okay, from 5 to going on to +1, we have decreased by -4. We have decreased by 4. This means -4 is going to be the change in here. So -4 is the change in the second nitrogen. And what about the first nitrogen? We are going from -3 to +1. We have increased by 4. So +4 is the second change. Sorry, the first nitrogen's change from from ammonium's nitrogen to N2O's nitrogen. So +4 and -4 are the answers. Now moving on to the next part. MCQ number 7. Alright, in MCQ 7, the Haber process of the manufacture of ammonia is represented by this equation, in which statement is correct about the reaction as temperature increases. Okay guys, when temperature increases, the rate of any reaction will always increase. Okay, just remember this fact. I'm talking about the rate. I'm not talking about the position of the equilibrium. Okay, the position of the equilibrium will change according to Le Chatelier's principle. But the rate of reaction with increase in temperature will always increase. So the rate of both forward and backward reactions will increase. Okay, because of more frequent collisions and hence more fruitful, more frequent collisions giving you more product. Now moving on to 8. Okay, this is an interesting question. They've given us a metal X and it reacts with an excess of chlorine to form this much grams of a compound. All right, so X reacts with chlorine to form HCl2. The mass of the compound is also given. Mass of chlorine we don't know in the question. It's not given, but the mass of group 2 element has been given. All right, now since we know from the law of conservation of mass that the total mass of reactants and the total mass of products is going to be the same, so using that law we calculated the mass of chlorine by subtracting the mass of the initial metal from the mass of the compound which has been formed. So we get 2.367 grams. Now using this mass value we can calculate the moles of chlorine, which turns out to be 0.033 moles. Now since we know from this stoichiometric equation that the mole ratio is 1:1, we can calculate the moles of X as well. The moles of X and the moles of chlorine gas are going to be the same. Now once we have the moles of X, we have the mass of X, we can calculate the MR by using the basic formula for moles. Once we have the MR, it is 7.6. We can compare it against the periodic table, and this 87.6 is the MR of strontium. So delta is the correct answer in there. B is the correct answer. Now what about question 9? Alright, question 9 is also pretty simple. Which mass of gas will occupy a volume of 3 dm cube at 25 degrees Celsius, 1 atmospheric pressure? Alright, so now room conditions are given and they've told us that 1 mole of any gas occupies 24 dm cube. So what about 3 dm cube of gas? 3 dm cube would occupy 0.0125 moles of the gas. Alright, so now we have to compare which of these have the same moles. Alright, which of these have the same moles? So we calculated the moles of each one of the gas, each of these gas, and so it's option C that gave us the same moles as the one we calculated. 0.125, so C is the correct answer. Now going on to the last MCQ of this video. Alright, the table gives a concentration of pH values of the aqueous solutions of two compounds X and Y. Either compound could be an acid or a base. Alright, now student P concluded that X is a strong acid. Alright, can X be a strong acid? Let's see. Okay, X has a pH around 6. pH around 6 is the pH for weak acids but not for strong acids. For strong acids, the pH must be as low as possible. 1 to 2 is the general range for strong acids. So student P is wrong. So A cannot be the option and C cannot be the option. Now we have a tie between B and D. Okay, now what about student Q? Student Q says that the extent of dissociation is lower in X than in Y. Okay, in X we have 6. The pH is 6, indicating that it is a weak acid. Okay, weak acid, guys, remember weak acids are those which partially ionize in aqueous solution or have a low dissociation, right? Low dissociation. So partially ionized, low dissociation. So yeah, X can be, this is correct that X would have a lower, it will have a low dissociation, but we don't know if it's lower than Y or not. Now let's check at the pH of Y. Okay, the pH of Y is 9. 9 indicates that it is a strong alkali. Okay, it is a strong alkali because they told us in the question that they can be an acid or a base. So it has to be a stronger alkali. And by the way, it is farther apart from the neutral range. The neutral range is 7, right? The neutral pH is 7. This 6 is close to 7, showing that the dissociation is low, and this 9 is further away from 7 as compared to 6. The difference between 7 and 9 is greater than the difference between 7 and 6. This indicates that the ionization of this alkali is greater. If the ionization of this alkali is greater, that's why it has given a stronger alkaline pH. Because now the keyword over here is that we just need to compare the differences. If the difference is greater, this means that yes, this has a greater dissociation. All right, y has a greater dissociation as compared to x because the pH of y is further away from the neutral pH. And if it's further away from the neutral pH, this means that it is a strong alkali, like at least is more ionized than the acid itself. All right, so Q is correct, only Q is correct, D is the correct answer. Okay, thank you so much. That's all for this video.